Hello, welcome back to TECHPLIXITY. If you are seeing our video for the first time, I want to ask that you please give us a big thumbs up on the video if you find it helpful, and then also please subscribe to our channel so that you will be notified whenever we drop new content. To our returning subscribers, I want to say thank you for choosing our content. And today we are going to be talking about OSI reference model and TCP/IP protocol suites. I made a video recently about the same topic. However, we still have a couple of things to discuss. Actually, we have a full playlist for this topic so that we can touch each one of the layers and topics carefully, and we can be able to share all our knowledge in all of those videos, and then we'll put them in a playlist, which makes it easy for you to visit anytime and then learn from this topic. So, from my previous video, I explained what the OSI reference model is all about and the benefits and some other points. But in general, I explained that OSI reference model is this model that helps us to understand the movement of data across the computer network. But I did not explain to you what computer network or networking is about. So today we'll be discussing a little bit about that, and then we'll move forward to other topics in OSI reference model. So what is computer networking? It is a set of computers that shares resources provided or available on the computer nodes or on the network node. And these computers or devices are connected via communication links that allows the devices to share information and resources. What is computer network nodes or network nodes? Network nodes are various devices in the network. However, it is popularly divided into two categories. That's like the router and the end devices. In this aspect, we understand the end devices to be the devices that communicate and connect directly to the router, while the routers are the ones that passes the packets across the network. That is how we categorize them. However, the network node is a multiple, or should I say there are numerous devices in this, under this description. So the nodes depends on referred network and protocol layers to form a network connection. And also we have here an example of a computer network. Here we have series of computers connecting to a server or a data center. So I just want to use an example of we are located, or this computer is located in different countries, and then we are trying to access Facebook. So let's assume that Facebook is the one in the middle. That's the server. So that's an example of a computer network. We are trying to, gain access to our information from the Facebook server back and forth. So this is an example of a computer network. There are so many ways we can actually describe this, but that is just a very simple way to explain to you what a computer network is and how it works. So moving on, we want to talk about the internet. The internet is a connection of two or more networks. If this is an example of a network, then we can imagine the internet, how big the internet is, which is a connection of two or more of these kind of network in order for them to communicate with each other. They consist of even thousands. That's the small internet with the I, like two or more, but the internet with the big I consists of thousands of interconnected networks. The internet is not a simple architecture at all. It is a very big space. It is a very big space made up of WANs, LANs, and so many other types of these area networks. And the connection between these devices can be wired or wireless. Just like the example that I made previously, if you're trying to connect to the Facebook server or to fetch information from a particular company, a database or server, you're not directly connected to those computers or servers or devices via wire, but you rather are connected wirelessly, So this is the kind of connections that we have when it comes to these devices that communicate with each other on a network. And before communication can happen, we need specific protocols and standards to be able to have a successful communication. And what is a protocol? Protocol are sets of rules that governs communication, and this is required for any entity or device that needs to communicate over the network. An entity, when we use the word entity in computer network, means anything at all that has the ability to send and receive data or information. So now we're moving on to OSI reference model. The last time when I talked about OSI reference model, I did not explain each layer, or I did not say anything about the layers in the OSI reference model. So right now, we're going to have more deeper explanation. So we have the application layer, we have the presentation layer, we have the session layer, the transport, the network, the data link, and the physical layer. So if you look at these layers, actually from the top is the 7th layer. They are all 7 in number. So the application layer is the 7th layer. The presentation layer is the 6th layer. The session layer is the 5th layer. And the transport layer is the 4th layer. The network layer is the 3rd. Data link is the 2nd. And physical layer is the 1st layer. So the numbering is from top to bottom. So in this aspect, we have certain ways that we study OSI model actually for easy remembrance, understanding, and also for clarity. So I'm going to be sharing some of those goodies with you right now. So first of all, let me number this. Okay, because this one is not numbered. Let's do 7, 6, 5, 5. We have 4. Let's number these. We have 3. We have 2. And then we have 1. This one. Yeah. So let's start from explaining how this model works. So there is something we call encapsulation. So since our model is labeled from top to bottom, that's 7 to 1, the process of encapsulation is when packets have added information as they go down the model until they reach their destination. So you see this arrow starts from the top to the bottom. So that process is the what? Is the encapsulation process, which means that at each layer, an header is added to the packet until it reaches its destination. So moving on with that, we're going to talk about abbreviations, how we remember this OSI model really easily, and then it's really fun. So, and that's how I learned this many years ago. So let's do this together. So we pick the first layer, which has the first layer at the top, which is the 7th layer. The first letter is A. The first letter for presentation is P. The first letter for session is S. The first letter for transport is T. The first letter for network layer is N. The first letter for data link layer is D. The first letter for the physical layer is P. So now we formed an abbreviation for this. It's been a very long time, and this is a very popular abbreviation, actually. I did not form it myself. So virtually a lot of people that has been studying computer networks for a while now, or that has been working in this field, knows this abbreviation. So it is all people, all people seem to need data processing. Just the same way, you see, all people seem to need data processing just like that. So that's how the abbreviation is. So let's go over it again. All people seem to need data processing. That is the 7th, 6th, 5th, 4th, 3rd, 2nd, and 1st layer of the OSI model in an encapsulation mode, which is from top to bottom. So let's move on to the opposite of this, which is the decapsulation process. The decapsulation process. Let me clean this away. Let me rub this off. Okay. So now we have the decapsulation process. This process is when it's the reverse, it's the opposite of the encapsulation. It is when the headers are being removed or the information are being removed from the packet as it moves up the model until it reaches its final destination. So this time around, we start counting from bottom to top, which is the first layer, physical, the second, the data link layer, third, the network, fourth, the transport, fifth, the session layer, sixth, the presentation layer, seventh, the application layer. The same way we did for the abbreviations is what we're also going to do here, but then we give it its own special acronym, which is we give its own special acronym, which is this one. Please do not throw sausage pizza away. You see this beautiful pizza over here? Yeah. Please do not throw sausage pizza away. How would you throw something so beautiful? So yummy, right? So it helps you to never forget about this OSI model and how it is labeled. So now, just a quick recap again. Decapsulation process is the reverse of encapsulation, and decapsulation does what? It removes the information from the packet until it reaches the final destination. So please do not throw sausage pizza away. So now let's move on to the next part. So this part, I'm trying here to explain to you how the header works. So it's the same thing we just discussed above, but this is a clearer picture to show you each layer, how it works. So at each layer, there's an addition of a packet. So this is like, let's assume this is like the data moving through through this OSI model. So the first one, we have this data, and then it moves to the next layer. There's an addition of what? Of a header. It's called the TCP header. So there's an addition of this header, moves to the 6th layer, to the 5th layer, to the 4th layer, to the 3rd layer, to the 2nd layer, and to the 1st layer. At each layer, there's an addition of an header. But mostly, when it comes to the 2nd layer, there is not just an addition of a header, but in this 2nd layer, there is also an addition of a trailer. In another video, I'll be explaining each of these layers separately, so you are going to get a deeper understanding. But for now, I just want to explain to you that there is always an addition of a header when the data is moving from top to bottom, which is the encapsulation process. But on the opposite side, when the data now moves from the from the sender, which is top to bottom, to the receiver, bottom to the top, then there is a removal of each of these header. There's a removal of each of these header, these ones. There's a removal of each of these header until it gets to the final destination as well. I hope that is clear. I won't dwell too much on that because another video I'm going to create also has much more explanation for you to understand. So I have not explained what each of these layers does. So let's start with that. What is the function of each layer in the OSI model? Starting from the 7th layer, which is the application layer. This layer is the layer that humans understand. This is the layer where we can access network services. So in the 6th layer, this presentation layer is a layer that ensures data is in usable formats. And this is where we have data encryption. The 5th layer is a session layer that maintains connections, and it is responsible for controlling ports and sessions. The 4th layer is the transport layer, and this layer is responsible for the transmission of data and with the help of protocols, which includes the TCP protocol and the UDP protocol. So TCP means transmission control protocol, and then UDP is user datagram protocol. We're going to explain deeply about these things, but for now, let's just take the brief explanation. Let's take it in little by little, gradually. So the network layer is a 3rd layer, and it helps us to decide which path our data takes on the network. The data link layer is the 2nd layer, and it defines the format of data on the network. And also the 1st layer is the physical layer, which helps us to transmit raw bit streams over the physical medium. That we mean the wired or the wireless, So that's the physical layer. So moving on to the protocols and the devices that we find in each layer. Let's move to discussing the devices and the protocols found in each layer of the OSI model. Let's start from the bottom to the top. In the bottom layer, which is the physical layer, we find devices like the hub, repeaters, network adapters, the SCSI parallel buses, the various physical layer. Ethernet incorporates both this layer and the data link layer, the token, rings, the FDDI, so many other. And also in the data link layer, we have the bridges and the switches. And the 3rd layer, which is the network layer, we have routers, we have layer 3 switches. Yes, I mentioned switch before in the data link layer, but we also have what we call the layer 3 switches in the network layer. That you're going to get many more explanations in the future video. However, in the network layer, we do not just have only devices, we also have protocols like the IP, IPX, and many others. In the transport layer, we have protocols like the NetBEU, which is the NetBEUI, the TCP, SPX, and many others as well. We also have the NetBIOS protocol in the session layer. In our presentation layer, we have NCP, AFP, TDI, and in the 7th layer, which is the topmost layer, we have SNMP, SMTP, FTP, Telnet, so many protocols in this layer as well. Let's move on to the next topic here. We have the PDUs. What are PDUs? PDUs are the protocol data units of each layer. How headers are being added in each layer as they move in the network. However, in this stage, we are talking about what each of those packets are called when they get to each layer. So a packet that moves from, or an information, let's use it this way, an information that moves in the seventh layer, or that exists in the seventh layer, is called data. In the sixth layer, they are still called data as well. In the fifth layer, they are also still called data. But whenever an information is in the fourth layer, we call them what? Segments. When they are in the third layer, the network layer, we call them packets. And then when they're in the second layer, we call them frames. And then when they're in the first layer, we call them what? We call them bits. So these are the PDUs of the OSI model. So at this point, we'll come to a conclusion. First of all, in my previous video, I explained to you I gave like a summary of the benefits or the use of the OSI model, but I forgot to mention to you that the OSI model is also a very helpful tool for troubleshooting. They help us to identify which layer is causing us an issue and helps us to focus our effort on that layer. If you, as an engineer, if you understand the OSI model really well, and you use this model while troubleshooting in your network, it will be a very seamless process for you, because you do not need to run around when you have issues in the company network, you do not need to run around and get confused or get distorted or even destroy the entire production network just to solve a problem. But if you use the OSI model as a guide, it will help you to identify where the possible problem is. You start to troubleshoot from the physical layer, trying to say, oh, are the cables rightly aligned? I hope like the RJ45 or the RJ11 is not disconnected from the switch. You check something like that. Oh, they're all fine. Nothing is, you check if the lights are blinking. You check if the connection is all right, or the cable is not bad. Then you move on to the next layer, which is the data link layer. You're trying to check the switches, the orbs, are they in the right, place? I hope there's nothing bad with the maybe one of the ports. Those things you check gradually. Then you check the routers, like that. You go up, 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 up until you are able to identify what the problem is. So let's move on. In this place, actually, I just want to summarize everything. So in this video, we've discussed various things. We've discussed about computer networks. We've discussed an example of the computer networks. We've talked about encapsulation and decapsulation process. We've talked about the abbreviations for how we can identify each layer. All people seem to need data processing. That's top to bottom. And then bottom to top, we have please do not throw sausage pizza away. Then we also talked about the headers being added and removed in the computer network as the information moves to and fro the network. We also talked about the functions of each layer in the OSI model, and we talked about the protocols and the devices you can find in each layer. And finally, we also talked about PDUs as well. PDUs, which is the protocol data unit in each layer. Before I round up, I would like to add some information as well. I would like to tell you that from the 7th to the 5th layer of the OSI model, these layers are mostly focusing on software. We call them the user support layer. So they are mostly software related layers. They allow interoperability among unrelated software systems. Let me take that again. The 7th to the 5th layer in the OSI model allows interoperability amongst unrelated software systems. And these layers, we call them in group the user support layer, USL. And then moving on to I'm going to skip the transport layer for now, but I'm going to move on to the third to the first layer. That's the network data link and the physical layer. These layers are called the network support layer, the NSL, the network support layer. So, and this layer as well, let's pick the third and the second layer. They mostly do with both hardware and software related things on the network. But for the physical layer, it's mostly hardware, right? All of them are the third, second, and first are called the network support layers, but the network and the data link layer has to do with both hardware and software, while the physical layer mostly deals with hardware situations, hardware things. But in general, the entire group of the network support layers helps the physical aspect of moving data from one device to another. You understand? Like it helps as the top layer helps us with interoperability. These particular layer groups help us with the movement of data from one device to another. And then finally, the heart of the OSI model. So whenever you ask the question, what is the heart of the OSI model? It is the transport layer. Without the transport layer, none of these things we've discussed, the USL or the NSL, can move well, because this is what helps us to transport information from one end to another. So it links the subgroup above, which is the user support layer, and the subgroup below, which is the network support layer. It links them together to ensure that the format of information that is transmitted is being understood. So, for example, the format of information that is being transported from the bottom, when it gets to the top, it's being understood by the top layer, which is the user support layer. And then vice versa, it ensures that the data that moves from the user support layer is being understood when it gets to the bottom layers, which is the network support layer. So I hope this video is quite explanatory. And also you can see the way this is nicely explained. We have the sender. When the sender is always from like the top, which is we have the application layer, as I explained earlier on. I said that is the layer that has the users that is user understandable. That's like, this is the place where humans really understand, right? So this application layer, that's where the sending begins from. So that's why we have sender on this part of the model and receiver on the other side. So that means our information is moving from the left to the right. And then when you want to also send back, it moves again backwards from the right to the left. So that's the way I have designed this, and I believe that it is well explanatory. So I want to say thank you so much for viewing. Thank you so much for staying up to this moment. I hope it has been really helpful for you. And if you have any questions, we have a form in the description box where you can post in your questions or special requests for a particular topic. Then we are going to treat that topic and then share with you on this platform. I also want to inform you that we have trainers-led sessions, like paid trainings, coming up in the month of May. You can look up our social media platforms to be able to get more information about this. So if you want a specialized training for IT support, for customer specialist roles, you can get those trainings from us. You can check more about it in our social media. Thank you guys for watching. Please do not forget to give us a like on this video. And also do not forget to also hit the subscribe button and hit the notification bell so that you'll be notified whenever we drop a new content. Thank you so much for watching and have a great day. I hope to see you again soon in the next class. Bye.